Every single time you click a link, stream a show, or, send a message, you're basically commanding an invisible army of information. But have you ever really stopped and wondered how that actually works? Today we're going to pull back the curtain on the most fundamental, the most overlooked, yet, honestly, the most crucial part of that entire journey. Okay, let's dive right in.
I mean, it seems so simple, doesn't it? You hit send and it just goes. But how? How do the words you type or the pixels in a photo get transformed into something that can literally race across a copper cable or just fly through the air? It's a really fascinating puzzle when you think about it.
You see, before it's a message or a picture or a video, your data is, well, it's just this. A long, long stream of ones and zeros. Just raw bits. You can almost think of them as ghosts in the machine. They represent the idea, the pure information, but they don't have any physical form. They can't do anything by themselves.
So, what's the missing piece here? What's the secret sauce that takes these abstract digital ghosts and gives them a physical body? Something that lets them travel through the real world?
Well, it is time to meet the protagonist of our story today. It's the part of the network that does all the heavy lifting but gets almost none of the credit.
Say hello to the physical layer. You'll also hear it called Layer 1 of the OSI model, and its whole job is to solve that ghost problem we just talked about. It's the layer that defines how to transmit those raw bits over a physical medium. In other words, it's the part of the network that gets its hands dirty with the real nuts and bolts, or in this case, the volts and the photons.
And here's what's so critical to understand. The physical layer's job is incredibly specific. On one hand, it's an absolute master of physical signals. It knows exactly how to represent a 1 with a certain amount of electricity or a precise pulse of light. But on the other hand, it is completely 100% clueless about what any of it means. It has no idea it's sending the letter H or the first pixel of a funny cat video. It only knows how to do one thing: turn bits into physical signals and turn physical signals back into bits. That's it.
So really, the physical layer is the ultimate translator. It's totally fluent in two different languages, the abstract language of binary and the very real, very tangible language of physics, of electricity, light, and radio waves. It's the indispensable bridge that allows the digital world and the physical world to have a conversation.
Now, this translation process isn't just random guesswork. For any two computers anywhere in the world to understand each other, they have to follow an incredibly strict and detailed set of rules. This rulebook is what guarantees that a 1 sent from a laptop in Tokyo is actually understood as a 1 by a server sitting in Toronto.
So what's in this rulebook? Well, pretty much everything physical you can think of. The standards define the exact type of cabling. Is it copper? Is it fiber optic? They dictate the precise shape and pin layout of the connectors, like that familiar plastic plug on an Ethernet cable, the RJ45. They even specify the exact voltage for a 1 versus a 0, and the data rates. All of this is to make sure everyone is speaking the exact same physical language.
And all these rules give us the actual hardware, the stuff you can hold in your hand. We're talking about the network cables, the metal connectors on the ends, and even your computer's network interface card. Its most fundamental job is at layer 1, physically sending and receiving those signals. This also includes some older, simpler devices like hubs and repeaters, whose only job was basically to grab an incoming signal and just shout it back out to keep it going strong.
Okay, so this brings us to a really important question. If layer 1 is just kind of dumb, just a signal blasting machine with no intelligence, how does it ever form a coherent message or a file? Who's telling it what bits to send and in what order?
The answer is that our hero, the physical layer, doesn't work alone. Not at all. It's actually the foundation of a much, much larger structure, a conceptual skyscraper for communication that we call the OSI model.
And this right here is the blueprint for that skyscraper. We start at the very bottom. Layer 1, our physical layer, that's the solid concrete foundation. Right on top of it, you've got layer 2, the data link layer, which takes those raw signals and organizes them into reliable chunks. Then layer 3, the network layer, acts like a GPS, adding addresses and figuring out the best path across the internet. And from there, the upper layers handle things like quality control, managing the conversation, and finally, presenting the data to the app you're actually using. Each layer adds more intelligence, but every single one of them depends entirely on the layer below it.
So why do it this way? Why all these layers? It's because, as the saying goes, this structure breaks down the complex process of network communication into smaller, more manageable parts. It's a brilliant design. It means a company in California can totally perfect a layer 3 routing chip, while a company in Korea builds a fantastic layer 1 fiber optic cable, and they can both be confident that their parts will work together perfectly.
But let's not lose sight of the main takeaway here. You can have the smartest, most sophisticated routing algorithms and the strongest data encryption in the world, but without that humble, hard-working foundation, turning ones and zeros into physical signals, none of it even matters. The entire digital world is standing on the shoulders of Layer 1. It all starts right here, at 1. It's the first step of the journey. It's the ground floor of the entire digital skyscraper. It is the absolute, non-negotiable starting point for every single bit of data you will ever send or receive. Period. So the physical layer really is the unsung hero of it all. It's the invisible, brute force workhorse that powers our sleek, elegant digital lives, tirelessly translating our wishes into the most fundamental language of the universe, energy. Which kind of leaves us with a final thought to chew on. The next time you plug in an Ethernet cable or hop on a Wi-Fi network, just take a second to appreciate the incredible journey your data is about to take, starting right there at Layer 1. And maybe ask yourself, what other hidden layers are working together right now just to make that simple connection happen?